Dear students, I welcome you all for the online learning platform for the course Warehousing Automation. So, this presentation will take us to the last chapter of Unit 4 Decision Making Process in Warehouse Automation, and today the topic what we are going to discuss in this presentation is going to be MCDA, or is also known as MCDM, Multi-Criteria Decision Making or Multi-Criteria Decision Analysis. So basically unit 4 discusses a lot about decision making. So the main agenda was decision making, so within which the unit was bifurcated into two halves. The first half we discussed about the various reasons, need, necessity of decision making, how the process was, what all are the different steps are there. So how to design and develop a decision making support system was also there. Then with respect to business goals and objectives, how goal should be there, how an objective should be there was discussed. So technology related selection as well as investment decisions was discussed in detail. And finally, optimal deployment strategy pertaining to the three core objectives of decision making, namely cost, scalability and compatibility was discussed. So that was the first half of unit 4. The second half dealt with the various tools and techniques. So namely there were 5 tools were there and 4 tools we have already learnt, and this is going to be the 5th tool. So by order, SWOT analysis, cost benefit analysis, decision trees, Pareto analysis and multi-criteria decision analysis is the topic what we are going to discuss. So before we get into MCDA, so now we'll just in a very brief manner we'll just recap the 4 techniques what we discussed, we learnt earlier. So SWOT analysis is one particular technique which is going to make a comparative comparison between two main elements, the negative elements versus the positive element. So strength and opportunities will be the plus and weakness and threats will be the negative. So that's how the comparison was done. It was a paid comparison. Then the next was purely with respect to finance, cost benefit analysis, which had some numerical data collection related to cost and how the benefit quantified. So it was between cost versus benefit. Then came decision tree analysis, which was a machine learning technique which essentially discussed about the graphical representation of the route to the various questions available, then to the branch node and finally to the leaf node. The fourth technique was Pareto analysis, where Pareto analysis is a part of quality control tool, so which essentially made a pairwise comparison between trivial many versus the vital few using the Pareto rule or the Pareto principle, also known as 80-20 principle, where 80% of the defects or the problems are due to the 20% of the causes. So how Joseph M. Juran invented the tool and why he converted the name or why he kept the name by means of an Italian economist by name Wilfredo Pareto, how the same 80-20 principle was affirmed, everything we discussed in the earlier presentations. And now we'll go about the final topic, MCDA, multi-criteria decision making. MCDA comprises potent techniques for structured, transparent assessment and prioritization amid conflicting factors. So now, what are the tools we have discussed? It was a consensus of a team. So there was no doubt. All the tools, whatever the tools we have discussed so far, they were there. But whether all the team will be unanimously, will they be accepting or narrowing down to one option means obviously no. See, if there is a multifunctional team comprising design engineers, manufacturing engineers and service engineers. So design engineers perspective will be different. Manufacturing engineers perspective will be definitely different, and service engineers, their perspective will be it will be different. Now, majority of the cases there will be conflicting factors will be there will be conflict among their opinion, there will be differences of opinion will be there. Okay, so all these opinions need to be considered. See, definitely there is going to be an strong underlying factor is going to be there among all their perspectives. You can't omit just like that we can't omit, and directly we can't go for an another option or a solution with some sort of ambiguity in it. With error, we are not ready to accept because it's not going to be a wise decision. Here we are not going to do emotional decisions. Here we are going to do rational decisions based on logics. So when we have such conflicting scenario, what tool or which particular tool will solve the purpose? So this is the biggest question mark what we have. So thanks to MCDA has been designed, has been developed to handle only conflicting factors in a very logical way. So it is going to use various mathematical techniques, numerical techniques are going to be there behind it in order to arrive for a solution. So we'll see how it works, what all are the different tools and techniques are there, how it is classified. So the complete data, the knowledge with respect to MCDA we'll be discussing here. So basically, traditional decision making process rely on intuition, experience or sold metrics like expenses or profit maximization, but real world choices involve balancing economics, societal impact, environment and technical viability. So usually from let me take the SWOT analysis, or let me get the last tool what we discussed was Pareto. So everywhere you see there were some sort of intuition or experiences was playing a very crucial role. So how to determine a strength? Obviously experience comes into picture. How to capture a cost? Experience comes into picture. What all are the different types of costs available? Again experience or intuition comes into picture. Some metrics were there, or you just directly get into cost benefit analysis where only finance was involved. So likewise, each and every tool was aligning itself to one particular asset or towards one particular core area of engineering or economy, whatever may be the case. But is there any tool to balance all these factors? We'll be having n number of factors. So n number of factors to be given some sort of weightage, or you wanted to go with an uniform weightage, or you wanted to have some sort of biased weightage based on the importance or based on the severity, whatever may be the cases. So is there any tool to accommodate all sorts of fluctuations? Means the answer was definitely no. But this particular technique is not so. So MCDA is going to be the classical, the best tool, so which is specially designed to balance all these platforms. So it is the one which is going to balance all these activities. So basically it acknowledges complexity, furnishing comprehensive framework integrating multi-dimensional objectives. This is very important. Multi-dimensional objectives, it decomposes knotty dilemmas into digestible components. See, please understand the term knotty dilemmas into digestible components. See, knots which are quite complex to resolve. So dilemma where we'll be having an oscillation, whether to go with this option or to go with this option. So immediately you might be having a thought process where we have got a decision tree that we'll go ahead with. Who frames the question? Experienced person is going to frame the question. How can we affirm the question is right? Some cases based on situation, the question will change. Definitely the question will change. Say when there is an advancement in technology, so likewise there are different things are there. So this knotty dilemmas should be changed into digestible components. That is, it has to be accepted by majority of the people. So how to go ahead with this? So that's where MCDA is going to pave way for it. By outlining decision biases, weighing importance and evaluating against each criteria. So this is what the nuances, the advantages of MCDA. So what it is going to do is the decision making is going to based on weighing importance. You are going to give weight factor. See, none of the tools what we discussed since SWOT were doing this particular activity. Numerically we never solved, we just solved only with respect to the available options. Weighing factor nowhere we discussed, but here weighing can be done, ranking can be done, likewise all sorts of activities can be done, and we are going to evaluate against each criteria. So there are several criterions are there. So criterions are going to be put together. We have got set of pair or some cases set of criterias are going to be there. So each option is going to be evaluated in a pair-wise basis. Pair-wise comparison is a mandatory among several tools. We'll see there are different types of tools and all the tools do the same but in a different way. The execution will be different but still they do it. So now what happens is, will it be going ahead? Will it give any sort of partiality? Means no. Why? Because we are giving weight factor for all. So the results will be impartial. It will be coming out with an impartial results. we'll have a qualitative data, we'll have quantitative activity. So all the levels of or all the people involved in the multifunctional team are given weightage, and therefore it is going to be an equilibrium technique where balancing is going to be existing for all. Now, what all are the traits of MCDA we saw? So now we'll see what is MCDA, how it works in a sequential way. We'll see. So MCDA means multi-criteria decision making, or MCDM is also it's also another term what we call multi-criteria decision methods. So MCDM provides a comprehensive framework to handle complex decisions by integrating diverse objectives such as cost, performance, sustainability, and stakeholder preferences. So what are the tools we discussed? They never had. So this point we are very clear in this regard, but it is going to accommodate all sorts of things. Okay. So actually we don't have any sort of numerical problems to solve, but actually speaking, there are different methods, or there even manually we can solve. There are softwares are available. Even Excel can be used to solve all these things. So here weightage is going to be given. Even uniform weightage also can be given. We can have n number of alternatives. So instead of relying on intuition or a single metric, MCDA organizes decision problems, defines relevant criteria, assigns weights to those criteria, and evaluates alternatives by considering both qualitative and quantitative data. So this is very important. Why? Because all the cases when we just take a by instance, when we go ahead with cost benefit analysis, we always we get cast in terms of quality. We don't have any sort of quantitative data. Perhaps if we wanted to go ahead with, means the tool is not in a provision to accommodate. See, in a decision making criteria we discuss a lot about adaptability, and we just go ahead with compatibility, but the tool what we use is not compatible. Means it just obeys the statement, like people who preach never practices. It should not be like that. Having discussed a lot about adaptability and compatibility, but the tool what we go ahead is not in a position to accept all these things, means then obviously it's going to be a wild goose chase. So therefore this MCDA is going to be the highest among the hierarchy of the tools what we have learnt in the earlier case, where it is very magnanimous enough to accept qualitative as well as quantitative data. Now we'll see the steps involved. Step 1, the first is define the decision problem. See, this is a purely applied for decision making. Of course, optimization can be done in a parametric base, but the main purpose is for multi-criteria decision making. So first define the decision problem. So how it should be, means clearly specify what needs to be decided, including alternatives and scope. So let me go back to the earlier concept what we discussed. We wanted to select a robot. There is a SCARA robot, and another option is articulated joint robot. So which robot should I prefer? So likewise, when we go ahead with clearly define the alternatives and the scope for each and every alternative. Second, determine criteria. List all relevant factors. It can be quantifiable, it can be intangible, it can be quantitative. Irrespective to it, just go ahead with the factors. Okay. Then the third step, assign weights to criteria. If you have got some sort of priorities for each and every criterion, go ahead. For instance, I don't know which has to be considered the important. If that is a situation, you may go for an external stakeholder, or you can get an idea of an other stakeholder, and based on their input, this process can be thought of. So how can it be, means now for example in the robot there are two aspects are there. Say for example energy efficiency is there, and the other thing is load lifting capacity. So which one weightage as a decision making guy, but I am confused in this regard. I don't know which one to be given more weightage, whether energy efficiency has to be given, or the other important case called as load lifting capacity, which one has to be given. So obviously what we do is we go to a stakeholder, say a service engineer. When service engineer is asked, he gives it a very clear case. That is, you don't worry about energy efficiency. Whether you lift 1 kg of load, whether you lift 2 kgs of load, the energy consumption is going to be however the same. So therefore, you just give least priority for energy efficiency. On a priority scale, give high priority for the case of load lifting. Why? Because we are interested towards operational efficiency rather than energy efficiency at this juncture. So likewise, we will be getting input from the stakeholders. Based on that, we can assign weightage to the criteria. We can assign weightage. Step 4. Evaluate alternatives. Score each option on every criterion using quantitative data or qualitative ratings as available. So now you have got options. So whichever the data you are having, either in the form of qualitative or quantitative, just go ahead and get it sorted. So compare them, come out with the standard alternative scores. Fifth step, combine everything, aggregate the scores, combine everything, go ahead with the ranking. There are different mechanisms over there. So now we get the ranking, different rankings we get. So option 1 is going to be scored the best, or likewise there are 5 options over there, which option is the best in the rank order, the way how we get after our examinations or so. So likewise we can rank everything. Now this is how the basic structure looks. So the first case you can see it is the goal. So this is the goal of the problem. For this case only we are working. So in our case right now what we are discussing is selection of a robot, either a SCARA robot or an articulated joint robot. So now we can go ahead with various criteria. It do not mean that since the diagram shows only 4 criteria means there is no 4 only. Okay, you can theoretically speaking it can be of n. For example, the cost, then compatibility, I am just putting it as CO, compatibility, then with respect to energy efficiency, load lifting capacity. Likewise, whatever the things we wanted to go ahead with, we can go ahead with n number of things theoretically speaking, and they need not to be qualitative, even it can be quantitative. Okay, it can be subjective, based on opinion also it can be. Then we can come out with an alternative. So now in this alternative, let me, since there are 3 columns are there, let me fill like this. The first thing is SCARA robot, then the next is articulated robot, and let me put the third as Delta robot. So we have got 3 options. Now we are going to do comparison between all these criteria with the alternatives. So likewise we will be doing in a very mathematical way, we will be doing involving matrix. So matrices will be involved in this regard, and we will be doing calculation, and at the end of the calculation what happens is we get the ranks. So say for example this is found to be second, this is found to be 1, and this is found to be 3. So likewise we get the ranks, and this is how we come to a decision in a very rational way, in a very logical way we come. We don't go, or we don't give any sort of importance to the emotions, just in a very engineering concept, by means of obeying all these engineering philosophies, we just go ahead with. So MCDA, it has got variety of methods, wider methods are there. So why? Because the main concept of decision making means it is with respect to obeying the conflict ideas. So people will be having their own perceptions, and it often it comes with a confliction in nature, that is difference of opinion. So the best practice is obey all the differences. So in order to abide that particular statement, MCDA is having different types of methods. So 4 methods are there, and within which again there are some different types of methods are there. So 4 basic categories. The first category is outranking methods, second value utility based methods, goal programming and reference points methods, in short called as RPM, GPRPM, goal programming and reference point methods. So goal programming means it's an optimization technique. Okay, it's an optimization based technique. Why? Because students of automation, mechanical and automation, already they have did this particular problems related to goal programming. Fuzzy, MCDA and uncertainty handling. So this is going to be an AI technique. Fuzzy logic is an AI technique. So fuzzy comes into picture for the case of MCDA. So the first, outranking methods are based on the concept of pairwise comparison. So pairwise comparison is going to be done between the alternatives. So earlier we saw the diagram. So there are 3 levels. First is goal. So that's the question. So let us discard at this juncture. We have got criteria versus the alternative. So pairwise comparison is going to be done for each and every cases. So the Two best methods are Electri method and Promethe method. Electri is an acronym for the abbreviation Elimination and Choice Translating Reality, and Promethe Preference Ranking Organization method for enrichment evaluation. So these methods belongs to this particular outranking methods. Okay. So actually these problems, rather than calculating manually, softwares are available. So we can just fill in everything, and whatever the data the system has, like weight factor, everything we give. So it is going to nicely solve and it is going to get us the results. Second, the second category is value utility based methods involving aggregating the performances of alternative scores, multiple criteria into a single value or utility score. Some popular methods in this category include AHP, ANP, TOPSIS and VICOR. So AHP is analytical hierarchy process, ANP an improvised version of AHP analytical network process, then TOPS is top order priority for the situation with respect to ideal conditions, and VICOR. So these all are the different tools. Again, these tools can be manually solved, but as such no softwares are there, but we can develop them by means of Excel. Microsoft Excel can be used to solve them. Even manually also it is possible to solve. Then the third category, goal programming and RPM, reference point methods, or optimization based approaches that aim to find solutions that satisfy multiple goals and reference points as closely as possible. So these methods are particularly useful when the decision maker can specify target or reference levels for each criterion. So now the case is, the problem is treated as an optimization case. So now there might be one question, why should we consider optimization to be in this particular picture? Means, see, optimization is the one which works based on the objectives. So objective will be of two natures, either it can be maximization or minimization, or some cases even it can be combination of maximization versus minimization. So using them also it is possible. So goal programming is one such optimization technique which is extensively used for decision making. So as I have been emphasizing during the presentations, students, during your mini project case or for your final project, or maybe with respect to career perspectives, think if you are interested in these areas. The last category, involving fuzzy. See, fuzzy itself, the term fuzzy means confusion, and based on this we have a logic AI technique called as fuzzy logic. Why? What is the reason for fuzzy logic is, see, majority of the problem when we design or develop at an infant stage, at the starting stage, the data and the information what we have will be very raw, in the sense it will be vague, it will be highly imprecise, errors will be there, and uncertainty will be the maximum. So when we have an imprecise and a vague data under these situations, how to go ahead is, that's where fuzzy logic is designed and developed for. Fuzzy logic is the best technique to handle imprecise and vague data. So fuzzy MCDA methods extends traditional multi-criteria decision analysis techniques to handle such uncertainties by incorporating fuzzy set theory and fuzzy logic. So it is the one which does all sorts of activities. Okay. So the simple takeaway here is, once the data what we have gathered will be having errors, that is imprecision will be there, as well as it will be vague, and fuzzy logic is the best method to handle such imprecise and vague data. And MCDM is a made aggregate part of it, therefore we get this fuzziness is going to take care of the vague and it is going to give a clear cut image, and MCDA is going to take that as a relay. And advantages: creates a transparent, well documented decision process, allows explicit consideration of diverse, sometimes conflicting criteria, so that is the main agenda here, facilitates stakeholders participation and consensus building. So once you are stuck out with at any point of time during MCDA, you are free to approach the stakeholders to know what is happening, and enables a trade-off and sensitivity analysis, leading to well-informed and defensible decisions. So the final conclusion what you come out with is going to be in a very rigid way, with very good amount of rational. If somebody is questioning you, then you are with facts you are going to talk, or not without facts. You are going to talk everything with respect to actual fact rather than assumptions. So these all are the benefits of MCDA. So now we are the end of the presentation as well in the end of unit 4. So with this presentation we finish not only the chapter of MCDA, even we finish unit 4. So to summarize what we discussed in this particular chapter is, there are 5 tools are there in the unit 4 of decision making. So among the 5 tools, 4 tools were in different applications, and MCDA is the one which is specially designed, developed for people with conflicting ideas, and practically conflicting ideas will be a part of the decision making process. So to obey all their constraints, all their requirements need, so we are going to adopt different types of MCDA. There are 4 methods are there, and within which there are different methods under that particular category. So any of the 4 category tools can be adopted. So they are right from simple calculations till handling the vagueness or the imprecise data. The tools are equipped, or that's the potential they have. So with this understanding, we'll just finish this particular presentation. So thank you students. Any doubts, kindly note it down. We can discuss the same during our online discussions or during our offline classes. Okay, thank you once again. So with this we complete unit 4. So in the next presentation we'll start afresh with unit 5. So thank you once again. Thank you for your active participation and learning. Thank you.